All right, our example 2, Luke, go ahead and read. Given.
Given a continuous differentiable function on the interval 0, 3, represented by the table below. Is there a value of x on 0, 3 where f of x must equal 0?
So f of x must equal 0, meaning the y value is equal to 0. So let's look at our table of value. The only one you're worrying about is the x value and f of x. So just by looking at this, is it true that there must be a value between some number that's going to equal 0? No. Let's check right here, f of x. If the number is continuous, and think about this, if I have to connect negative 2 and 1 of those y values, is it a guarantee that it's going to cross at 0 at some point? Yeah. So I'm going to write 0 is going to come somewhere in between. It doesn't mean exactly in the middle, somewhere in between. So we know, yes, is there a value? Yes, there is. And I'm going to write out by intermediate value theorem, negative 2 is less than 0, less than 1, and specifically with the domain, f of 0 is less than 0, less than f of 1, because 0 and 1 is between negative 2 and 1 of the f of x. So I'm going to write out there is a value of x on the interval. Now for my interval, we're looking at it from 0 to 1, because that's the interval I chose. If you choose to write 0 to 3, it is still correct. Isn't 0 to 1 still within 0 to 3? As long as it is within, it's good to go. But I want to be more specific, where f of x is equal to 0. So you have some freedom, but just don't overkill it. So let's go to part B. On part B, Mason, go ahead and read that piece.
Is there a value of x on the interval 0, 3 where f prime of x must equal 0?
All right, so this time we're looking at f prime of x must equal 0. And let's just look at f prime of x. When I look at the f prime of x, I see 5, I see 3. Whoa. Is it pretty obvious right there? Yeah. I know you're like, duh. It's like a freebie. So we know, yes, f of 2 must equal 0. I guess that's enough to say, right? What if that 0 was not there? If that 0 was not there per se, because I know a lot of you guys were like, well, that's duh, so easy. Could I have taken the average between, not average, the slope between these two numbers, y2 minus y1 over x2 minus x1? Wouldn't that still give me 0? So if you wanted to even write out, so if you want to write this piece, go for it. This is extra. Or I could say yes, by the mean value theorem, f of 3 minus f of 0 over 3 minus 0, and specifically, negative 2 minus negative 2 over 3 is also 0. So on your AP test, not every table is going to give you a 0 very explicitly on there. If not, find the slope value where it's going to give you a 0, just like when the two numbers are equivalent. So that's another way to look at it. But I know most of us want to stick with the first one, which is perfectly fine. All right? Okay, part C. Addison, let's read.
Does f of x have any point of inflection? If so, at what value is x?
All right, so we have point of inflection. Let's go ahead and underline that. Point of inflection has to do with f double prime. And let's see if we have a point of inflection. And look at our cards, actually. Okay, on our card, point of inflection happens when f double prime goes from positive to negative, or vice versa. So let's look at the double prime. On our double prime, we have 2 to 0. That's not positive to negative. But look at 2 to negative 3. Is from 2 to negative 3 actually changing from positive to negative? What about from negative 3 to 1? Is that changing from negative to positive? So whichever one you pick, let's go ahead and write out. Yes, for this one, f double prime changes signs, and I'm going to go ahead and write out for this one between 0 to 2. Or if you want to be analyzing the graph further and say we have 2 to 3, they're both correct. Because at 0, positive. At 2, it is negative. And same with at 2, it's negative. 3, it's positive, as long as it's changing sign. All right. Kate, part D.
Does f of x have a relative extrema? If so, how do you know?
All right. Does f of x have a relative extrema just by looking at this? Which one? When that number is equal to how many? Uh-oh. Relative extrema happens whenever we have f of x or f prime of x is equal to how many? 0, thank you. So let's write out f prime of x. And in this case, we have has a relative. Is it a minimum or maximum we have on that one? If it is going up and it's going down, is that a minimum or a maximum? Max. At x equals 2. And if you want to be even more specific, you could write out f prime of 2 is also equal to 0, which represents the maximum right here. Or here's another way I want to look at it. I want you to look at the number down here. F double prime is what kind of number? Okay, so let's look at our chart. When f double prime is negative, do I have a relative maximum? Yes, I do. Okay, so that's why our little chart is very useful. Okay, let's kind of recap on tangent line. I'm still having kids not knowing how to derive what to plug in where, but that is a reality. So, Edith, go ahead and read the example. Consider
f of x equals x cubed plus 5x squared minus 30.
next one.
A. Write the equation of the tangent line to f of x at x equals 1.
So our tangent line, we need a point, and we also need slope is equal to. The good thing about it is the fact that we have x value is already given to us. To find the y value, should we plug it back in? So f of 1. So we have 1 all cubed plus 5 1 all squared minus 3. Someone tell me how many that will give us.
1 plus
3. 3? We okay with that?
Yeah.
To find the slope, we need to find the derivative. So let's find the derivative. F prime of x is 3x squared. Not everyone's writing, so good luck to you. Plus 10x. And then how many is that? Is that it? So I need to plug in the 1 into it. So I have f prime of 1, 3 times 1 all squared plus 10 times 1. And that should give us 13. Are we okay with that piece?
Yeah.
So let's write out our formula. Not the formula, let's plug it in. Y minus a y1 is 3 is equal to our slope times x minus the 1 is 1. You can leave it like this. You can go on further. It doesn't really matter. I'm okay with this. Because you remember on the AP test, if you're correct at the beginning and you simplify incorrectly, everything above is incorrect. Okay? So if you're pretty definite about this one, stop right here. All right. Part B, Castro, read.
Use the line from part A to approximate the value of f of 1.1.
Okay, so the line from part A. So I'm going to draw the arrow. We're going to now plug it in for 1.1. So we have y minus a 3 is equal to 13 times 1.1 minus the 1. So we have y minus a 3 is equal to, if I just compute the inside, isn't that 0.1? And if I take 0.1 times 13, we should get 1.3. So our last thing, we're going to add 3 on both sides. We get 4.3. All right, let's see what that basically means. So this is the approximated value. Approximated value on our tangent line. So what I want you to do is draw a line somewhere. And we know just by looking at this, well, you might not, but I already know that it's going to be concave up. And that piece we're going to deal with on part C. I'm kind of jumping ahead. And let's say this point right here is 4.3. What can we anticipate about the actual graph of the y value? Is it above or less than 4.3? So this is the actual graph. This right here is the approximated tangent graph. It is above. So let's plug it in. If I plug in 1.1 all cubed plus 5 times 1.1 all squared minus 3, and yes, we should need a calculator, but I'm going to say I could do this in my head, which I can't. Do we actually see that that number is bigger than our approximated value? And the reasoning is because it's concave up. So let's go ahead and prove why it's above. Our f double prime of x. If I find the derivative from the f prime function, we're going to get 6x plus 10. And when I plug in the number, I believe 1.1 into this function, it's going to be some positive number which is greater than 0. And we know when f prime or double prime is greater than 0, it's going to be concave up. So that pretty much proves it. I wish these two questions could kind of flip. Oh well. So I'm going to re-explain this real quick. So I need all eyes on the board. Because my graph is concaved up, the approximated value is always less than the actual number, and you can see it's taller. So then what can we anticipate about when it's concave down with the tangent line? And some point, I could put a point over here. Is our approximated value higher or lower? It is, the approximated value is higher. So we know concave down is going to be an over approximation because our approximation is above. Concave up, that point right here is under approximation. It is under the U.